Okay, today we're going to do the bookwork for 11-3, interpreting the shapes of data displayed. So we're going to talk about skewness again. We're going to be looking at a lot of different histograms mostly. So, example 1, the histograms show the weights of all the dogs entered in 2 different categories in a dog show. Consider each data set. What inferences can you make based on the shape of the data? So if we look at this data here, if we drew a line above it like this, we can see that has that nice bell shape. So the histogram is symmetric. And when it's symmetric, that means that the data is evenly distributed around the center. So the mean and the median are equal or almost equal. Now if we look at this data over here, if we drew a curve on it, we can see that we have a tail here on the right side, so that means that it's skewed right. So the histogram is skewed right. And this means that the mean is greater than the median. All right, next. Try it. Suppose a third category of dogs has a mean of 40 pounds and a median of 32 pounds. What would the shape of the histogram be? So if the mean is greater than the median, that would mean that the histogram is skewed right. Next, example 2. Interpret the shape of a skewed data display. Customers of a bagel shop complain that some bagels weigh less than the amount on the label. A quality control manager randomly sampled 30 bagels and weighed them. Based on this sample, is a change in the process for making bagels warranted? So quality control people, they basically, in a factory setting, they look at how the bagels are made, and they might, have to do some tests to see if there is a problem. Because when you're putting out a product, you want it to be the same every time. You don't want it to be, like sometimes your bagel weighs this much and other times your bagel weighs that much, because, you have your serving size here. One bagel is supposed to be 90 grams. If it's more than that, it's going to be obviously more calories, more everything, and people need to know that, right? Now, we have to keep in mind here that grams is a really small amount. A paper clip is like a gram. So when you're only dealing with a few grams, it's really not that big of a deal. Just keep that in mind. So if we look at this data here, it is skewed left because we have a tail on the left side here, okay? And it says the mean weight is 87.7 grams and the median weight is 90 grams. So the bagel is supposed to be 90 grams, but it's saying the mean is 87.7. So the bagels are weighing a little bit less than the median in this sample, and that's because it's skewed left. Now, take note that he only sampled 30 bagels, and that's why it says n equals 30. Sampling 30 bagels is not very many bagels, okay? So we're going to write the histogram is skewed left. The mean is lower than the median. However, he only sampled 30 bagels. So he should sample more bagels before making a change. So as we can see, there could be a problem here because these bagels are weighing less, but he only sampled 30 bagels, and it's not that much less. So we're going to keep going and see what happens now. Example 3, compare shapes of skewed data displays. Okay, the manager generates a second random sample of 30 bagels. Is a change in the process for making bagels warranted based on this sample? How does this sample compare to the previous sample? So how does this one compare to this one? So this data is skewed right. So we have a tail on the right side. Okay, so this sample, that's bothering me. Okay, this sample is skewed right. So now the mean is higher than the median. So it's kind of like, that's confusing because in this sample, the mean was less. In this sample, the mean is greater, 87.7 grams. 7 grams greater seems significant, but it's only like 7 paper clips. I mean, it's not that big of a deal. So he still only sampled 30 bagels. So that's still a problem. So the manager should still sample more bagels before making a decision. All right, next. Example 4. Interpret the shape of a symmetric data display. The quality control manager generates a third random sample that contains twice as many data points. A histogram that represents this third larger sample is shown below. Based on this sample is a change in the process of making bagels warranted. So now he tested 60 bagels, and it said that the mean and the median weights are both 90 grams. And that is because the data is symmetric. Draw a curve over it and makes that nice bell shape. So the data is symmetric. The data is symmetric. The process of making bagels does not need to change. So now that he tested more bagels, it's symmetric, and the median and median are both the same. So he really just needed to test more bagels. Okay, example 5. Comparing the shapes of data sets. Jennifer is considering job offers from 3 different school districts. The histograms show the salary ranges for 3 similar positions in each school district. What do the shapes of the data tell Jennifer about the teacher salaries in each district? So just to give you a little bit of background on this question, teacher salaries, at least in New Jersey, I think most states are the same way. Basically, you start at a certain point, and then every year you make a little bit of more money. So maybe your increase is $500, maybe every year your increase is $1,000. Usually you increase very slow, and then once you get to a point of teaching for like 5 years or so, then maybe your increments go up $2,000, something like that. So, you know, you might start around, let's say, $50,000, and then you might top out in like the 80s, something like that. So that's kind of how teaching salary, that's how it works. And obviously every state is different. Some states you make more money, and some states you make less money. Okay, so if we look at this first school district, this is symmetric, okay? And the mean is 52,000 and the median is 53,000. So the mean and the median are really close, and that's because the data is fairly symmetric. So the salaries of the teachers are fairly evenly distributed. Okay, so that means like that in this school district, you have some teachers on the lower end of the salary guide. You have some like, you know, first year, second year, third year, fourth year teachers. And then you have some teachers that, you know, have been teaching for, you know, 20 something years. And then you also have your teachers that are right in the middle, teaching between like 10 and 15 years. So your data is very symmetric. It's not like you have a lot of teachers on the high end of the salary guide, and it's not like you have a lot of teachers on the low end of the salary guide. It's just all pretty evenly distributed. Okay, so next, for this, we can see that the data is skewed right here because we have a tail on the right side. So the data is skewed right. Most teachers have salaries lower than the mean. Only a few teachers make a higher salary. So basically, most of your teachers are making money somewhere in here. And then you have a few teachers, like 80 to 89 here. You have a few teachers that are making a lot of money that have been in the district for a while. But most teachers are on this end of the salary guide. So that kind of means, so your mean is 48,000, your median is 42,000. The mean is 48,000, higher than the median because it's skewed right. So those people that are making more money are bringing the mean up, okay? However, the median is only 42,000 here, and the median was 53,000 here. So we have to keep that in mind that in this school district, probably making a little bit less money. All right, school district 301. Okay, so this data is skewed left. Okay, so we have a tail on the left side. So the data is skewed left. Most teachers have salaries higher than the mean. Okay, so most teachers have salaries that are going to be greater than the mean. So the mean is 65,000 and the median is 70,000. What could that mean? It could mean that, you know, this is a higher paying district. It could also just mean that there's, you know, teachers that have been in this district for a while. There's a lot of senior teachers, you could say. So when I look at these, I would think that this is a good school district. This is a good option pay-wise. And I would say that this is probably a good option salary-wise. School District 201, since the median is only 42,000, I would say this is probably a lower paying district. So maybe she'd want to rule that out. Okay. Try it. Suppose a fourth school district offers Jennifer a job. School District 401 has a mean salary of 57,000 and a median salary of 49,000. Okay, so the mean is higher than the median here. Should Jennifer consider accepting the job offer with School District 401? Well, the median is only 49,000, and then it's skewed right because the mean is higher. Mean is 57,000. So I would say no. The mean is so much greater than the median. So the teacher salaries are skewed right. There are a few teachers, most likely on the high end of the salary scale. So there's going to be a few senior teachers in the school that are kind of pulling up the center, and that's why the median and mean are so different here. So I would still consider School District 101, School District 301. All right, that's it. You're gonna have to do some practice problems now. I hope you have a good day.